Hey guys, today we're going to learn mean, median and mode. So what is mean, median and mode? Mean, median and mode are basically types of measures of central tendency. As we did in our past section, we know that averages are basically indicators of the central point or central location that a data values in a data set seem to tend towards. So that's the central tendency that averages generally measure, right? So those central tendency can be measured in a multitude of ways. There are several statistical measures of central tendency or averages. These are essentially types that you will learn if you ever pursue higher statistical education or anything in the field of statistics or economics. For the purposes of our low entrance examinations, there are basically three types of measures of central tendency that we need to be very familiar with. They are the arithmetic mean, the median, and the mode. Let us see what these three types are and how to calculate them in a sum that might come in a law examination. First, arithmetic mean. Arithmetic mean is basically what we understand when we say averages in layperson terms. It's the most commonly used measure of central tendency, and it's something that is taught to students at a very young age under the guise of averages as such. It is basically defined by the general formula of averages only. So it's the sum of all of the data values or observations in your data set divided by the number of values or how many values you have in that data set. So the formula would thus be sum of all values divided by the total number of values as such. When we say average in layperson terms, so when we say find the average of XYZ values, we generally mean to find the arithmetic mean of all of those values. So that's basically arithmetic mean. Fundamentally, it's the same thing as what we understand when we say averages in general. The process to calculate arithmetic mean is identical to the process to calculate averages that we learn as the general formula. So the first step we need to do is add all of the data values to find the sum of all the data values. Step 2, we need to find the number of values that are there in the data set, which we will express through a variable like n. And step 3, we will divide the sum of all the values that we get in step 1 by the number of values that we get in step 2, and whatever the result is essentially the arithmetic mean of the given data set that you have. So if you have X number of values, you add them all up, you divide them by X, that's your arithmetic mean. What's median? Now, median is something that is very different from an arithmetic mean in general, as it does not really have a fixed mathematical formula as such. It refers to a positional value. So, for a median, you essentially need the data to be in a certain order, right? Median is that positional value in a data set which divides the entire set into two halves essentially, with the left half having all of the values that are less than the median and the right half having all of the values that are more than the median. So the median essentially cuts the whole thing in half. It acts as a central point, a median point for the entire data set. Right? So it's the middle element when the data set is arranged in any particular order, either ascending or descending, in order of magnitude or in order of the value of the numbers that are there in the data set, right? So in ascending or descending order, if you arrange a data set, the value that will come in the middle will be your median. In this scenario, unlike calculation of arithmetic mean, where your data values may be disorganized or just put in any sort of order possible and the sum will still remain the same, to calculate median, you necessarily need these data values to be in an order of magnitude arrangement, right? So you necessarily need them to be in an increasing or a decreasing order, or you will not get an accurate value for median. This is a primary difference that median has with arithmetic mean. And this is a fundamental difference that will come in mode as well. So mean is the only one of these three types of measures of central tendency which really does not need an arranged or organized data set in order of magnitude or anything of that sort, right? So how do we calculate median? The calculation of median doesn't really have a formula as such. It's just an intuitive process. So first what we do is we arrange all of the data values in order of magnitude, either increasing or decreasing, right? So ascending or descending order. We must make sure in this case to write each separate occasion of a single value separately, right? So if you have a data set where say a value x occurs 5 times, you will write x down 5 times when you're writing it in ascending or descending order, right? You cannot write just x one time and be done with it. Each occasion of the value needs to be written to accurately find the median to the problem. So this is something that we must keep in mind while calculating median. We cannot simply take a value and put it once for calculating median. Each time it occurs, we have to put it separately in our data arrangement as such. We will then find out the total number of values, or n. If n is an odd number, you will essentially have a single middle value. You will have a midpoint to that arrangement, which will be the n plus 1 by 2th value, which means n, you add that by 1, you divide that by 2. So the number that is the position. Whichever value is in that position in your data arrangement will be your median. In a situation where the number of values is even, however, you will not really get a midpoint as such in your data arrangement to actually find a median. You will get 2 values in the middle. So when you have an even number of values to calculate median with, what you will do is you will take the n by 2th value, whichever is the n by 2th position, the value there. You will take the n by 2th plus 1 position value, which is the next value to n by 2 plus the n by 2th value, and then you will add those two and you will divide them by 2. So you're essentially taking out the arithmetic mean of those two particular values, and then whatever answer that is will be your median. So that's basically how to calculate median. It will become much clearer when we do the examples at the end of this session. What is mode, right? So mode in this situation is the most frequent value or observation that you have in your data set. Say in your data set you have a multiple number of values. The value that occurs the most number of times in that data set is essentially the mode. The word mode, and this is a little tidbit to just remember what mode is, essentially derives from a French term which means fashionable. So what this means is essentially the value that is the most fashionable, or the value that appears the most in your data set, is going to be the mode, right? So that can be a way to essentially remember what mode is. Unlike mean or median, which will be unique values for each data set, you will have one mean or one median for each data set. You can have a number of mode values for a single data set. You can also have no mode values for a single data set. This is because mode depends solely on the frequency of the values. So if you have multiple values with the same frequency and this frequency is the highest, you will essentially have multiple modes. It can be bimodal where you have 2 modes, or multimodal where you have more than 2 modes, 3 or 4 modes as such. However, if all of the values have the same frequency, this means that nobody is actually higher than anyone else in the frequency column, right? Which means that there will be no mode in this situation. This essentially means that you have to remember that if you have a number of values in a data set, there must be at least one value that is there in the data set that will not be a mode. If all of the values are coming out as mode, that means that that data set essentially has no mode at all. This will again become clearer in the examples that we do. To calculate mode, we don't really have to do much. We don't have formulae as such. We will simply arrange it in ascending and descending order. This is done to make it easier to calculate the mode. It's not necessarily something that we must do. We can count the different value frequencies from the data set in a disorganized way as is given. However, it's much easier to actually arrange it so you can see how many times each value occurs at a glance, right? Then we note the value that is there with the highest frequency, and that's our mode. The value or values that will be there with the highest frequency will be our mode values. In an arrangement, again, where all values appear an equal number of times, there is no mode. Now let's move on to a few examples to kind of exemplify how exactly to go about calculating this. The first example, let the ages of 15 people be 11, 15, 13, 18, 12, 11, 16, 17, 16, 15, 16, 19, 18, 15, and 16. These are the different age values of 15 people. So this is your data set. These are your data values. Therefore, n, which is the number of values in your data set, is 15. Mean in that case will be the sum of all of the values that you have in here, which comes out to be 228, divided by the number of values, which is 15. So your mean essentially comes down to 15.2. This is again a calculation based problem. However, we use the sum of all values divided by the total number of values formula to reach the result for mean. Then we arrange the data. Here I've arranged it in ascending order. However, you can go ahead and arrange it in descending order if that is something you're more comfortable with. Whichever one is your preference. The only thing we remember is that it needs to be in order of magnitude. So it needs to be either increasing to decreasing or decreasing to increasing. So we arrange the data in ascending order. We get two occurrences of 11, then 12, 13, 15, 15, 15 three times, 16 four times, 17, 18 twice, and then 19, right? So that is our data value that has been organized or arranged by order of magnitude. So what then is the median in this case? Because this is an odd number, you will have a middle value, a singular middle value, which will give you the median. That will essentially be again the n plus 1 by 2th term, which will be the 16 by 2th term or the 8th term. Count in your arrangement which the 8th term is. Here the 8th term is 16. So your median is 16. For mode, the value that occurs the most will be mode. Look at your arrangement in the organized manner. See which number occurs the most times. It's 16 clearly from this example. So your mode will be 16. Let's move on to another example. Let the data values in this case be 1, 3, 5, 4, 2, 6, 5, 2. So there are 8 values. N is equals to 8. The mean, again putting it in the same formula, will be 1 plus 3 plus 5 plus 4 plus 2 plus 6 plus 5 plus 2 divided by 8, which is 3.5 as the calculation has been given in the presentation itself. We now arrange the data in ascending order. Again, this is up to your discretion, which order you want to arrange it in. And we get the arranged or organized data. In this case, however, there will not be a single middle value of the median that will give you the value directly because this is an even arrangement. So you don't have a middle point for the value. So you will essentially take the n by 2th term, which is the 4th term, and the next term, which is the 5th term. You will add them together and then you will divide that by 2. The result of that will come as 3.5 for this particular data set. So that's how median essentially for even values works out. Mode again is the same thing, the value with the most frequency. In this case, however, note that both 2 and 5 occur twice each in the arrangement and everything else occurs 1. So the highest frequency is 2 and there are two values which have this highest frequency, 2 and 5. So both are mode values in this case. We have two modes. This is a bimodal arrangement and 2 and 5 are both modes in this case. For the third and final example, the number of fruits that are eaten by a group of friends. Each friend eats, say, 1 fruit, 3 fruits, 2 fruits, 6 fruits, 3 fruits, 1 fruit, 6 fruits, and 2 fruits. So separately, these are the values of fruits that have been eaten by a group of friends. The number of values in this case is 8. In that case, the mean for this value set will essentially be 1 plus 3 plus 2 plus 6 plus 3 plus 1 plus 6 plus 2 divided by 8, which is 24 by 8, which is 3. Now we arrange the data in ascending order, which gives us the arrangement 1, 1, 2, 2, 3, 3, 6, 6. Now we again find the median. Since this is again an even arrangement of data, we will have two values in the middle, which we will take out, and then we will take out their arithmetic mean, and the result to that will come as 2.5 in this case, as the calculation has been given in the presentation itself. The mode here, note, will not be there. There will be no mode in this data set. Why? Because all of the individual values 1, 2, 3 and 6 have exactly the same frequency. So we won't have a mode that is displayed in this value. So basically this is how you do mean median mode problems. As in a following session, we will probably do some sample problems which will elucidate how to do this further. However, these are the fundamentals of mean median mode that we need to know for law entrance examinations as such. These will usually be given in association with graphs, which we will again do in some later sessions as such. That is it for this particular session. I thank you for attending it. I hope you learn mean median mode and you practice to the best of your abilities and you get to attend perfectly and accurately all of the problems on this subject that you might have in your law entrance examinations. Thank you so much. That's all for today. See you next session.